So, hello everyone. Uh, in this video, we'll be demonstrating our push to talk, aka radio signal demodulation project completed in GNU Radio for WCM 555. This is me, Adhan Jelin, and Shaun Abraham presenting the project. So, for this project, our main goal was to analyze and demodulate a recorded walkie-talkie transmission and record the voice message clearly from the audio radio capture. So, this was the output that we got.
Good job. You've successfully recovered the audio. Now make sure there is no static or noise in the signal.
Okay. So, on the technical background, push-to-talk radios typically operate in a narrow band FM modulation. So, these radios usually have like a voice bandwidth of 12 kilohertz. So, knowing the specifications through outside sources helped us select the correct demodulation block and design filters to isolate the target channel.
So our flow graph starts with a file source block that reads the captured IQ data. Since the signal wasn't centered at 0 Hz, a complex signal source and a multiply block shifted into baseband. The local oscillator frequency was adjusted to the negative offset to align the carrier for demodulation.
And as for the channel filtering, the mixed signal passes through a low pass filter with a cutoff of 12 kilohertz and a transition width of 3 kilohertz, which isolates the desired narrowband FM voice channel and removes unwanted frequencies. And the next output just goes to a simple squelch block that like mutes the static noise and everything when there's no active transmission.
The filter signal was fed into an NBFM receive block with a 240 kHz quadrant rate, 48 kHz audio rate, 5 kHz max deviation, and 75 microsecond toe for de-emphasis. The standard narrowband FM settings ensured accurate demodulation
And after demodulation, we focused on clearing up the signal, removing background hairs, low frequencies, hums, to make the voice and to make the transmission clearer. So our audio chain uses a DC blocker, a high pass filter, a low pass filter, and then it just feeds to a multiply constant, which controls the volume. So the DC blocker removes like the offset hums and everything, and the high pass filter to like remove rubble and sub-audible noise. And the low pass filter we use just to like reduce high frequency hiss and everything, and it just feeds to a multiply constant blocks, which controls the overall volume of the transmission.
Running the flow graph, the FFC display shows the signal centered perfectly and the audio sync outputs a clear, recovered voice transmission. There's only a tiny bit of static right at the end of each message. That's normal for push-to-talk radios caused by transmitter tail before the skull is
In
closed.
summary, this project demonstrated like how to isolate filter and like demodulate a push to talk signal, and we successfully performed the frequency shifting, decimation, and NBFM demodulation, and produced a clear voice output. And we cleaned up the signal as a little bit as well. So, and just for clarification, we'll play the audio again.
Good job. You've successfully recovered the audio. Now make sure there is no static or noise in the signal.
And there's a little bit of like static noise that comes through after the message. I think that's typically the case for every walkie-talkie that's there. Yeah, that's about it. And for references, we use Lab 3 and some like outside sources like uh, GNU Radio Companion User Manual and stuff. And yeah, that's about it. Thank you for watching.